out here in San Francisco this week. Different shows, Citrix Energy. So these are the two shows Citrix puts on each year. One for their partner and reseller community, and then that leads into Synergy, which is its user show that'll happen later this week. This last month, Citrix also added me as a what they call a Citrix Technology Professional CTP. So that's the equivalent of the Microsoft MVP program.
I'll figure this out.
And
go ahead.
Can I continue?
Yeah, go ahead.
Please continue.
Okay. So the CTP is Citrix's equivalent of the MVP program. So we had a great meeting, about 35 other people from around the world talking with Citrix about some of their longer-term plans. So we had Citrix in the house last month, so we don't really need to talk about what's new and going on here, because I think Matt did a really good job of talking about XenApp 6 and the desktop and the provisioning server. So what I want to do is take advantage of the opportunity to get a company that's one of the startup companies in virtualization space that we haven't been able to get out in Boston. So I'm pleased to have with me here the CEO and founder of Atlantis Computing, located out here in Mountain View, California, Chetan Venkatesh. Okay, so I'm just going to put him on the phone. He's got some slides. Hopefully you're hearing them or seeing them at this point, and we'll go through. We'll try to leave a lot of time here for Q&A, even though we're short.
On the bottom.
Thank you, Tim. Thanks very much for the opportunity.
That's on his screen.
Hi, everyone. My name is Chetan Venkatesh, and I'm actually the CTO and founder. We just hired a CEO a couple of months back, so I get to do all the fun stuff without doing all the hard work now. So, real pleasure to be here with you all over the phone. I've got a few minutes, and I'd like to talk about Atlantis Computing and what we do in the virtualization space. We're very heavily focused on solving a couple of very important challenges that kind of tend to dog desktop virtualization specifically. Desktop virtualization is just a very exciting technology. Everybody understands that there's a huge amount of value from this transformation that's happening on desktops by taking them off the edge and bringing them into the data center. All of that is happening at the cost of a very large problem. The problem is storage. And the storage at the data center is just not a viable platform for hosting and the kind of applications that typically tend to run on desktops. So Atlantis Computing has been focused over the last 3.5, 4 years on building some intelligence into the software layer that allows you to slap a piece of software on top of any kind of storage, whether that's SAN or whether that's NAS or even directed at storage or local disk, and make that storage something that is optimal for hosting and running desktops from the data center. So we call this technology primary storage optimization, and we've commercialized this technology over the last 3 years. We ran a market last year, and the product's actually started to get a lot of excitement, a lot of traction, especially among some of the early adopters for large-scale desktop virtualization, which is in the financial services industry, which is within healthcare, education, and government. So some of the largest EDI infrastructures that are out there today in production, chances are that they're running Atlantis, because Atlantis really solves the key challenge. There are two really big challenges within virtualization, desktop virtualization, and Atlantis solves those. One is being able to do more with less storage. Virtualization is just an extremely storage-intensive application. It consumes vast amounts of storage, and that storage is in the data center, so it's very expensive. We solve that problem by allowing you to right-size the storage infrastructure and be very lean on the kind of storage that you deploy for VDI. The second problem that we solve is one of end-user acceptance. Desktop virtualization's biggest problem has been the fact that users are trading a desktop that, it used to run on a physical PC, had great performance characteristics, mostly worked, and now they're trading for something that's subpar, that's in the data center, that's several milliseconds away. And from a user experience standpoint, it just doesn't measure up, in terms of performance and fidelity. So that's the second thing that we solve. We basically accelerate these desktops and the storage platform in such a meaningful way that the experience of using virtual desktops is a very powerful experience. Then it becomes something quite akin to almost a Ferrari-like experience. And as a result, it kind of diminishes all these barriers that come from end users having a resistance to using a virtual desktop. These are kind of two of the large problems. we've solved with our software. I'll quickly go in and start to talk about the technology and what it is that the technology does. So let me start by just quickly getting a little bit of context into the problem. You know, what we're doing with desktop virtualization is a little crazy, because if you think about it, we're taking an architecture that's about 15 to 20 years old, and I'm trying to flip slides here. There we go. We're taking an architecture that's 15 to 20 years old that was defined around the Windows operating system mostly by the Intel and Microsoft guys. And there's some basic architectural assumptions around the PC and Windows that need translation when we virtualize. So if you take the PC or the x86 server, it's usually a physical box with all the main componentry within that case. So you've got some memory, you've got some CPU, most importantly, you've got some local storage, and you've got networking out to connect these PCs up. And the operating system Windows over the last 15, 25 years, you know, has really evolved as this architecture improved. But the one thing that has remained constant in this architecture is the presence of a local disk drive. So if you look at the history of the PC, from the beginning up until now, there's always been some form of storage locally attached that the operating system could read and write very cheaply to, so it could make constant reads and writes again and again. So when you have that ability, you tend to leverage it in different ways in the architecture. So as a result, Microsoft has done a lot of things around the operating system with virtual memory, with the way it does security, with the way the NTFS file system is written, that really relies on cheap and fast access to disk. The other thing is, when you think about a user's PC, it really is that user's PC. It's not a multi-user environment inherently, so that storage system, in many ways, is a one-on-one relationship with that user, and usually has more than enough performance within that mechanical spindle to service that one user. Now, when we virtualize these desktops, we kind of manage to somehow keep the compatibility at the application layer, but that compatibility comes at the expense of the storage layer, because what we've done with virtualization is we've taken that locally attached spindle and moved it away over the network into its own dedicated enclosure. So now what you have is this notion of a virtual hard drive. What used to be physical and one-on-one with the user is now virtual and completely logical. And so when the user is in his virtual desktop and he sees a C volume, it really doesn't correspond to any sort of a mechanical spindle or the characteristics that come from owning a mechanical spindle or having a dedicated amount of performance that comes from that. Your C volume simply is a file that lives in some virtual abstraction layer called a LUN, which itself is physically distinct from all the mechanical spindle underneath it, and there's some software that's handling this. And what used to be per disk is now simply a file that is a part of a much larger array. And you're now starting to share that storage infrastructure with all the other users and all the other applications that are running on that system. So the biggest problem with virtualization and this breakage in storage is that we've moved away from a dedicated storage relationship for the user and the desktop to one that is shared. And as a result, there's an enormous contention because my I/O now competes with everybody else's I/O to be serviced from the storage layer. And number two, because the storage layer is distinct and no longer locally attached, there's a latency involved in fetching all the I/O and processing all the I/O every time the operating system or the application or the user does something. To think about it, it's fairly ridiculous. Every time you even move your mouse over the start menu, because of the way Windows is written, it needs to go and fetch some information from disk to populate even those start menus. In a virtual desktop, that operation of mousing over the start menu generates enough I/O that it has to go over the storage area network, queue up at some storage array somewhere, be fetched from the spindle and be serviced back, while being in contention with every other kind of I/O that's going on. So when you start to really do this virtualization at scale, VDI starts to consume a lot of storage, not just because the virtual machines are large, it's just the amount of I/O that's required to power all these virtual machines is just not available. So as a result, you need to add more and more spindles or disks to be able to generate the IOPS. So, people kind of understand that VDI, very storage heavy workload, but the real reason it's storage heavy is not just because it consumes a lot of physical storage capacity, but really because of the amount of IOPS that each of these VMs